Hello everyone, good evening. Welcome to another video of today. Okay, so last time I had taken a video and where I had provided an architecture. Let me go back to that slide. Yeah, so last time we had performed something like semantic search where we just interacted with the native code and we had the index created in Elasticsearch and the embeddings was done in SBERT and we were able to query a small question and answer KB. Okay, so and then at the end of the session I think I provided another architecture where we will be you know, as a future enhancement we can go about using the LLM endpoints to provide the retrieved data as a context to an LLM and get the proper chat response from the LLM itself. Okay, so today what we are going to do is we've just implemented a small demo. Okay, so this is not going to be a tutorial, so I thought I'll just give a quick demo of what is being done, and then maybe I'll run through the code and explain in detail at a later point in time. So in last time in this architecture, I think the we did not use Langchain or any other vector DB or we used the SBERT embedding endpoint. But for today, what we are doing, so we are using Langchain. So Langchain is a very powerful, library. It allows us to interact with LLMs and other in the vector database. It makes life easier for building chatbots and anything related to LLMs. Okay, so we'll be using LangChain, and for embedding we'll be using the OpenAI embedding, and for vector database we'll be using Pinecone. So Pinecone, I just created an account, so it was just 5 minutes free account. So on the free tier we can have one index created. I think for the demo purpose one index should be fairly sufficient. So Pinecone is available in all three major cloud marketplaces, AWS, GCP, and Azure. So the one that we are going to use, it's internally it is using GCP, but I think if we have an AWS infrastructure in your organization, it should be fairly easy to find Pinecone in the AWS marketplace and get it started and running. Otherwise, we can still use OpenSearch or anything else. But the thing with Pinecone is that it was built ground up as a vector DB, and it is better performing than the Elasticsearch or the OpenSearch. Again, not put it to test, but that's the reviews that's coming for Pinecone. And for LLM endpoint, we are going to use the GPT-4. Okay, so I've just signed up in OpenAI and had some credits in OpenAI. Oh well, let's quickly go through the code. Again, I will not be explaining the code a lot, so I'll just be quickly running through the code. So I have the code running already in, again, I've run this already in Google Colab, so the code is available here. So the first step is we are installing the required Python libraries, and then the next step is to import them. Okay. And now, so here we will be uploading our documents. So we want, within a Langchain, we have directory loader, which would read the directory, and then it can help load the files. Okay, so here what we do is that first we load the files and then we split them. This is called as chunking. So we split the files into smaller chunk sizes, and we vectorize it, and then we store it in the vector DB, for indexing, and then we do this retrieval augmented generation. Okay, so here I have already I just googled and found some a financial statement of world whatever WIPO. And besides this, I thought we can maybe upload few other files. We can maybe, I thought of uploading some stories, but let's do something else. Let's reference paper. Okay, so these are some of architecture for this one, some of research papers in NLP. So mostly it was sarcasm related. So I just uploaded those documents. Okay. So now what I am going to do, I am going to run this block. So you can see that the documents are getting loaded. Okay, at the end of it, we'll display the total number of documents that we are loading. Okay, so it says we have 4 documents. As you can see, we have 1, 2, 3, and 4 documents. We have put the documents in PDF format. I think it should be, taking in normal docs as well. Okay. Okay, so the next step is chunking. So let's split the document into size of 1,000, and then there will be an overlap. The overlap is to ensure that we don't the uh, it does not miss the context. Okay, so after splitting, we have 447 chunks. Okay, and then we are setting the open API key. Here I will be changing the API key. So again, I'll be deleting this. This is another uh, requirement. And for embedding, we'll be using the OpenAI embeddings, and we'll be using the text embedding ADA model. Okay, and for sample, we are just showing, we're just giving this word and see what is the embedding size. So it's 1536. Okay. So now what we are going to do is that again, this is for Pinecone, we need to initialize the Pinecone, and we need to create the index by giving the documents and the embeddings. Okay, and then the index name. Okay, so for Pinecone, I have this application created, and we can go about creating the index. So again, we are already using the name here as Langchain demo, so we will, again, it means that we have to we again, we need to first have an index with this name. Okay, so what we will probably be doing is we'll be having this index, and then so what will be the dimensions? So dimensions will be the length of the embedding set is going to be there. So it should be 1536. Okay, and as for a free plan, this is good enough. So I'll just create the index. Okay, now you can see the index is created. Okay, so you can see the vector count is 0, so we do not have anything in here. Okay, now what we are going to do, so what we are going to do, this is the API key. Again, I will be changing the API key. I'll be deleting this API key, and the environment name is where do I get this? Yeah, so it is here, right? So it's the GCP starter. Okay, so and the index name is this one. So we are trying to index the documents. So here are the documents. So we have the documents, split documents are here, and we are taking the documents, and then we are using this embeddings, and then we are using this index name, and we are loading it into the Pinecone. Okay, so it is going to take a bit of time. Okay, so it is completed. Now we define a function to find the similar documents and return. Okay, so it is going to return the top two similar documents. Okay, now the next step is to we are going to declare, instantiate the LLM endpoint. Okay, so what we are here again, okay, we are using the GPT-4 model. Okay, and we are using the Langchain to instantiate it, and we are writing a small function where we give the query, and it is going to get the similar documents, so using this function, and then it is going to sorry, is going to generate the answer and return back. Okay, okay, now I had previously done something. Okay, so so here see, in this answer part, we just give the get question, and we can just hit the query here directly. So I thought we can just provide the answer in bullet points and see how it goes. And let's see. So let's open this document. I have it opened here. Okay, so I don't know what is VPO, so I don't know what data it contains. So let's randomly go through it. Okay, it looks like financial data. Excuse me. Mm-mm. Okay, what question can we ask this? What is this? Okay, let's ask what is the financial position of VIPO? Okay, let's put it this way. What is the financial position of VIPO? Excuse me. Okay, so we can see that. Okay, so you can see that it has provided the answers. Okay, sorry for that. Okay, so we will just ask this question and it is able to provide the answer in, we asked it to provide the answer in bulletin points and it is able to provide the answer in bullet points, and we have asked it to provide the reference documents, and here it is able to provide the reference document as well. So this is the document name, and it says that, okay, this is from this section, it is able to provide this answer. Okay, now let us see if okay, one thing that I probably forgot to show you is when we created the index. So initially you might have seen that there was 0, right? So now you can see that the vector count is 447, so which means, so as we keep adding it, the vector count is going to keep on increasing, and this just provides the the source. It says that, okay, where did I find this information? Okay, so this is the source that will be uh, see here what it is doing is that it is taking the source details, and it is kind of beautifying it, and giving it in a format where it's under, probably we can modify the prompt in such a way that, okay, you don't do anything, just give the document name as the reference. So that should also work. Okay, let's go on and quickly see another one. Let's see sarcasm bot. Okay. Okay, let's ask this generic question. What is sarcasm bot and what does it do? What is sarcasm bot? Sarcasm bot, and what is sarcasm bot, and who developed who developed it? Okay, let's ask this question. Now this is a bit of a tricky because the generally the language models gets trained on a huge number of corpus data. Okay, let's see. Okay, this is interesting. Okay. Sarcasm Bot is an open source sarcasm generator module for chatbots. It was developed by Aditya Joshi. And okay, let's see. Was it developed by Aditya Joshi? Ah, yeah, correct. So it is developed by Aditya Joshi. So it is kind of okay, but the references, I think it's got messed up with the references which are provided in the the document and what we are trying to. So again, this is just a prompting thing. So maybe if we fine tune the prompting, this should come out properly. But otherwise, I think it's able to. Again, if we can you elaborate uh, uh, on, can you okay, can you summarize the architecture of sarcasm bot? Let's see how this is kind of, I don't think I need this thing, so I'll just go ahead with query directly. Okay, the first stage is an input analyzer that analyzes it. Eight sarcasm generated to choose from. The third stage involves the which is used to remain in practice. All three modules are rule based and hexagon. Okay, again, I think this is coming from the paper. Let's see. Is it three stages? 2 3, yeah, so it is probably again they might have explained this diagram here somewhere, so that's why it is able to tell that, right? So it's again, I would not expect it to read the flow chart and answer, so probably they might have explained it somewhere here, and that's why it is able to clearly tell that it's three main stages: input, analyzer, generator, selector, and sarcasm generator, which is actually fine. So let's see how this answer gets changed if we had it as a prompt. Okay, so this is good. This part is going to confuse this one because there is a huge number of you know references provided in this paper, right? So at the end of it, there is a references sections and there is a huge number, so it's going to get confused. But architecture of same stages. Yeah, this is actually reasonably good, right? So it is able to go through this document and provide the details. So let's see if what is this one? Let's see. Um, Unsupervised sarcasm generation. No. Why I have so many papers on sarcasm generation? It's because I did my research in sarcasm generation. I was not able to complete the research, so I did sarcasm deduction instead of generation. Okay. Mm, let's see. Let's see. Again, I'm looking for a question. What kind of a question I can ask? Four system sarcasm bot. Okay, so they have referenced the sarcasm bot here, which is a good thing. Uh, hmm, let's see. Okay, how does flip work? Let's ask this question. How does flip work? Okay, now this is again going to be a very, because flip is a very generic term, and I can find it in a lot of places. And as I said, the LLMs are generally trained on a huge language corpus, so it would definitely have come across this word, or maybe even the paper itself is it's based on heuristic rules for automatically reversing sentiment in a statement. See, this is actually awesome, right? So it is able to clearly identify, okay, this is the flip paper that we are referring to. Again, look at this document. This is definitely good. Okay, I think the references part is kind of messed up because of the references which are provided over here. I think maybe with a better prompting, it could do a better job, but otherwise, it's doing a reasonably good job. Okay, let's see the this paper also, but also explanations. Okay, what is unique about Chandler? Okay, let's ask this again. It's fairly straightforward question, but because all the three papers are similar to each other, I should have done a better job at getting some different papers. But at least the Vivo financial statement was a different one. What is the unique? What is the unique? It's unique unique feature of. Let's do this. The word feature is not very right, uh, but says the first sarcastic response is that does not solely rely on predefined patterns. Okay, so this is actually good, right? It has probably read this entire paper and is able to tell that, okay, it does not rely on predefined patterns, it focuses on explainable generation. Look at this, it's focuses on explainable generation, which is good thing, and it's based on specific linguistic theory. Well, it's fine. Unfortunately, footnotes are not provided as text to be like. Okay, again, it probably got a uh, chunk of text which does not include the references, and maybe it got mixed up. Okay, but again, this should go to to us providing a better prompting. So I think yeah, so that is pretty much what I wanted to show today. Again, the code is very simple. It's fairly straightforward, right? Very limited code, and that's the power of Langchain. And another thing is that see, even Pinecone itself, right? So uh, provides you can create your own chatbot application directly from Pinecone. So you can upload the documents into Pinecone, and you can vectorize it and start asking questions to Pinecone directly. But again, we do not know what underlying chatbot LM that it is using, and how that would work. So and the cost is also the fairly cheap. Pinecone is fairly cheap. But anyway, so at this point we are able to do this. So here, from a cost perspective, I think the Pinecone, we're using a free version, but on a production grade scale, we will not be using a free version. And similarly, OpenAI, I am using my own personal account, but on a production scale, I think it's going to be different. So from a cost perspective, I think we can still go ahead and use what mm, some open source Falcon or Claude or any other open source language models which are available there. And besides the running cost, it would fairly be cheap to get it running. Again, infrastructure cost, because the infrastructure cost, the API calls and everything is going to be very cheap. And similarly, for embedding also we can use some open source model. And for vector DB, I think Chroma DB, or there are few other open source vector DBs available as well. So literally we can get this done for free, provided we have the infrastructure to support. So obviously the infrastructure cost, that is something that we will never be able to avoid, but at least the other cost we can avoid. Okay, so that concludes the demo. Hopefully I will come up with a better uh, uh, video where I can provide more details. Okay, thank you. Bye bye.